So as you know, last time we just looked at some periodic functions in general. So what we're going to do, it seems what we're going from and then what we're going to today might seem unrelated, but I promise you the periodic functions we did last time and our sine and cosine functions, these two will come together in the next couple of lessons, okay? So don't think that it's completely unrelated because it's not. Seems like it a little bit at this point, but once we get into the graphs, plus you with sine and cosine functions, you'll see very clearly how these all relate. So with that being said, we are going to just start off by talking about how angles are described in trig. So in geometry, you guys look at an angle being two rays that are just connected, okay? In trig, we describe angles differently, okay? Angles are measured in a counterclockwise direction from the x-axis. And we think of angles as rotations. So again, in geometry class, you guys defined an angle as being two rays with a common endpoint, just kind of somewhere floating in space. But what we do here is we define an angle. So let's start on this positive side of the x-axis. And let's think about that segment rotating some amount. And you guys know from Algebra 2 last year that we typically use that Greek letter theta to indicate that rotation or that angle. So we're thinking about taking that x-axis and rotating it. That's what creates the angle. So any positive angle measure is a rotation that has gone counterclockwise. If you are given a negative angle measure, that is a rotation going clockwise. So it's a difference in the direction of rotation. So let's say we have an angle of 30 degrees. And actually the picture I drew looks about 30 degrees. So starting from that positive portion of the x-axis, we would rotate 30 degrees. That would be the measure of that angle. And because it's positive, we go in a counterclockwise direction. So if we have an angle of negative 330 degrees, first of all, from that x-axis, which way am I rotating? Clockwise. Do you know where this ends up? It's called the terminal side of the angle. Yeah, so think about this. The whole circle is how many degrees? 360. So if I'm going 330 degrees clockwise, like Hannah said, that angle actually ends up in the same place as positive 30 degrees. Those are called coterminal angles. That's a term that you would have seen last year in Algebra 2. It just means that they're angles that share that same like ending or terminal side, okay? Okay. We are not going to get into, I don't think we're going to do a paper plate in here. We'll just do it on a piece of paper. We're not going to get quite to creating our unit circle yet until next week, but we do want to discuss what it is. So the unit circle is the circle that is centered at the origin. So the center is 0, 0, and it has a radius of 1. Circle has a radius of 1. The equation of your unit circle is just x squared plus y squared equals 1. So if you look at the unit circle, we very clearly know the coordinates of those 4 points. Because remember, our radius is equal to 1. So that has to be 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So if I asked you, let's say we have a rotation of 90 degrees. Rotation of 90 degrees. Or an angle measure of 90 degrees. Where does my terminal side end up? If I'm rotating 90 degrees. Where does that blue segment end up? Yeah, it rotates all the way up to here. So if I'm taking that coordinate and I'm rotating it, you can pretty easily tell me the coordinates of the new point. What we're going to look at in just a minute are finding coordinates, let's say, of an angle of 22 degrees. Okay? The multiples of 90, those are the easy ones. But do you know if I go 22 degrees, where the coordinates of that point would be? That's what we're going to do here in a minute. Before we do that, I have just a couple of things for you to do. It says in this example, mark the following angles on a unit circle. We're going to stop there, and then we'll come back to the rest of this example. So mark the following angles on the unit circle. Very similar to how we did the 2 angles up here on the first circle, how we did 90 degrees down here. So in one color or another, let's look at 100 degrees. And this is a little bit of a guesstimate, but you can have a pretty good idea where that's going to end up. Eric, run up to the screen and show me about where 100 degrees would be. Yeah, that's good. So 100 degrees, we know we're going past 90. So you show the rotation with that arrow, and then we can label the actual angle measure. Negative 200 degrees. Negative 200 degrees. Lauren, run up and show us about where negative 200 degrees would be. Yeah, that would be about right. So because it's negative, we're going clockwise. Half the circle is 180. So what she said about right here would be about right. Make sure you show that rotation going clockwise. Okay. What about this next one? 1,000. What happens here? Hannah?
You go past it like a couple of times.
Yeah. How many times do we go around? I forget. It probably, yep, it's twice. So 1,000 degrees, I'm going to rotate one full revolution, that's 360. I'm going to rotate one more time through. So out of 1,000 degrees, I've rotated, 640 total? That leaves you with 280 degrees. So I'm rotating another 280 degrees. That ends up just a little bit past the 270 mark. Oops. Questions on that? I saw some confused looks. Haley?
I'm just trying to make
Oh, well, don't worry about that. All right, real quick, then I want you guys to do that last one, negative 45 degrees, if you haven't already. That should be in your fourth quadrant about halfway. It's actually exactly halfway. All right. So here's the next big thing for this lesson. Like I mentioned, finding coordinates of points after rotations of 90 degrees or of multiples of 90 degrees, that's not hard because those are your 4, 0, 1, -1 points. But what about finding coordinates of point P after a rotation of 156 degrees? For that, here is where our sine and cosine functions come into play. Okay? So your definition of sine and cosine. Suppose point P has the coordinates x, y, and that is the point on your unit circle specified by some angle. So basically, it's a point along your unit circle. Where it is depends on how much you've rotated. We define the function sine of theta, or excuse me, cosine of theta, or for short, cos of theta, cosine of theta, and the sine of theta by the following formulas. The coordinate, the y-coordinate, is equal to the cosine of that angle of rotation, and x is equal to the sine of your angle. I just did that completely backwards. Oh my goodness gracious. X is cosine. Oh my goodness. Holy cow. So sorry. I know. What am I thinking? I even looked right at my paper, even though I know this. I looked at my paper and wrote the wrong thing. So sorry. X is your cosine of the angle, and y is sine of your angle. Oh my goodness. Make sure you change that. Holy cow. And it even says it down here. In other words, cosine of theta is the x-coordinate, and sine of theta is the y-coordinate. It's Friday, right? All right. So what that means is this. If we have an angle of 100 degrees, and I want to know the coordinates of this point. So here's our angle of 100 degrees. What are the coordinates of that point? We find the cosine of 100 degrees and the sine of 100 degrees. You remember doing this last year? Okay. One quick thing though. Make sure that your calculators are in the correct mode. So go to mode on your calculators. Make sure that you are right now in degree mode. If it's in radians, you are not going to get the correct answer. Make sure that you are in degree. So I'm going to find the cosine of 100 degrees. That's negative 0.17. That is the x-coordinate of that point. Sine of 100 degrees is the y-coordinate of that point. I'm going to explain to you why this is in just a moment.
So how do we get our calculator like that? 'Cause I got something.
Well, on yours, I'm not sure, Eric. I would have to look at it.
Alright.
For us, it's under our mode.
But what do you set it to?
Degree. You want it on degrees, not radians.
Okay. I can do that.
All right, so for negative 200 degrees, so think about your rotation of negative 200 degrees that ended up, I think that was our blue one. What we're finding are the coordinates of that point after you've rotated negative 200 degrees. Again, all you have to do is find the cosine of negative 200, which is negative 0.94 if we round, and the sine of negative 200, which is 0.34. That is the y-coordinate of your point. Okay? So cosine of the angle for x, sine of the angle for y. Holy cow, I can't believe I screwed that up. If you feel like you need to do the last two to complete your notes, that's fine, but I'm going to go ahead and skip over to why this is true. It would be so great if, I would just tell you, okay, to find x, take the cosine for y, take the sine. That would make your life so nice and easy if I just told you that and you're like, okay, I believe you, and you went on with your life. But that's not what I do. I have to tell you why. I don't like just telling you things and saying believe it because I'm the teacher. I want to show you why, especially at this level. So here's the deal. This goes way back to geometry class. Hope you remember your geometry. All right, so we have some angle. It looks, 40 degrees. It doesn't really matter. We have some angle, theta. Remember, this is the unit circle. So what does that mean? That means the radius is 1. What did I draw here from the center to the circle? The radius. So that has to be 1, right? What?
Yeah.
What?
Yeah, I did.
What?
The cosine over the sine. And
Yeah, we're going to go back to our sine and cosine ratios. So think about this. If I'm looking for the coordinates of that point, I'm looking for the amount that we have gone in the x direction, right? That's right here. That's our x. And then I am looking for how much I've gone vertically. So this distance is y. What did I make here, guys? What kind of triangle? A right triangle. I've made a right triangle. So Haley's kind of seeing where I'm going with this. We're going way back, like I said, to basic geometry trig and looking at our ratios of sine and cosine. So if we think about the sine of theta, do you remember what the ratio is for sine? Opposite opposite over what? Hypotenuse. Very good. Yeah, Mallory. So remember that the sine of your angle, that's the ratio of the opposite side over the hypotenuse. Well, from this angle, what is the opposite side? And what's the hypotenuse? So sine of theta equals y. Oops. I know, right? We can do the same thing for cosine. Cosine is your adjacent side over your hypotenuse. From our angle theta, what's the adjacent side? Hello? I said from our angle theta, what's the adjacent side? X. And our hypotenuse is still 1. So cosine of theta is equal to x. Holy cow. By the way, this is not in your book. I just felt like it was important for you guys to see that. So you can feel blessed that I gave you extra.
I feel like you talked about this though, like.
Oh, we totally did this last year. Yeah, we totally did this in Algebra 2, at least in my class. So, but just wanted to refresh your memories because we do have a couple that did not get any trig in Algebra 2. So, all right. So let's look at another example. So find the coordinates of point Q at an angle of 130 degrees on the unit circle. Again, all we're doing is taking the cosine of theta for x, the sine of theta for y. All right. Don't make this hard. Please don't. The only thing you need to make sure that you do is make sure that your calculators are on the correct mode. I did have somebody last year, bless her heart, did the whole trig test with her calculator and radians.
Did you let her retake it?
Of course I did. She won't care if I tell. It was Ellie Perryman. I was like, Ellie, you did so bad. Like, and then I did a couple problems with my calculator and radians. I was like, oh my God. So your coordinates would be negative 0.64 and 0.77. Okay. Do you have any questions so far? Like I said, you really did. I know there are a couple of you that are the exception, but the majority of you did all of this last year, which is kind of nice that we've added trig in Algebra 2. I love it, so I'm good with it. It is. I love it. It just makes sense. Like, it just makes sense. All right, so here's the deal. The very, very last thing that we are going to do is, even though we're mostly focused on the unit circle here, what if we have a circle that has a different radius? Okay? All we really do is we multiply the cosine and sine of that angle by the radius to get the coordinates. Okay? So the coordinates x, y of a point P on a circle with radius r is given by x is just the radius times the cosine of theta, and y is the radius times the sine of theta. So the only difference is you have to take into account that your radius is different. You are just going to multiply cosine or sine of the angle times your radius. Okay? So if you look at these last two examples, it says to find the coordinates of the point P at the angle on a circle with radius 4. Okay? So for 70 degrees, again, x is going to be your radius, which is 4, times the cosine of 70. And y will be your radius 4 times the sine of 70. And then you guys can go ahead and finish that. I would suggest that you do the sine and cosine part first, hit enter, then at the end multiply it by your radius. But that's just me. So take about 2 minutes to finish this up and then do the second one on your own.